And now we're continuing on our discussion about IP networking, and this time talking about an introduction to switching. Exactly what is switching, how does it work, why is it a benefit to us, and how can we use that moving forward? Well, to talk about switching, let's talk about how things work in a hub type environment, or an environment that doesn't have switching enabled. So in this hub environment right here, we have a hub with 7 different ports and 4 different PCs connected to them. And then each of these PCs has a MAC address associated with it. These are not real MAC addresses. Obviously, the real ones are much bigger. But we have a scenario. AAAA wants to communicate with CCCC. So we basically want to go up and down. And we want to do that as efficiently as possible. Well, the way that a hub works is not very intelligent and not very efficient. Basically, what happens when AAAA wants to communicate, he sends his message up into the hub. The hub then sends that message down to every single client on its device. Every single port that has an active connection gets that packet. I guess I should clarify, everybody except the sending port gets that communication. So the packet goes from AAAA out to everybody else, and then when CCCC wants to respond back, CCCC sends his message up, and then again, it goes out to everybody except for the sending port. Now, with only 4 client devices, this does not seem that big of a deal. These devices are all designed to look at the MAC addresses of the packets and be able to say, is this for me? If not, throw it away. However, once you get beyond, well, really beyond 4 devices here, the way that the hubs work starts running into a lot of issues. You end up with a lot of performance issues. Because of the way that these collisions occur, or I'm sorry, the way that this traffic occurs, you're only able to operate in what's called a half duplex. So you're only able to send half as fast as you normally would. Along with that, you also end up with collisions. Basically, what if A wanted to send at the same time that B wanted to send? Well, you end up with a collision, and essentially both of them have to drop off their communications and then start over again. So a hub, really with less than a dozen devices, probably will work fine. However, if you start getting to any kind of an area that requires performance or scaling beyond just those handful of devices, you're going to need something bigger, which is a switch. So here we have exactly the same scenario. We have AAAA wants to communicate with CCCC, except this time we're using a switch instead of a hub. And a switch has a MAC address table. So let's go ahead and walk through this. So AAAA sends up his packet into the switch, and what the switch does is it looks at this MAC address table, specifically looks at the MAC addresses, and says, hey, I don't know AAAA. You are a brand new person in my environment, but I see you're coming in on port number 1. So what I'm going to do is I'm going to take that information and I'm going to go ahead and throw that into my MAC address table. I now know AAAA is on port 1. And so if anybody tries to talk with AAAA, I simply go out to port 1. Well, that's great. That's very handy. That's very friendly of him. Great to direct people along to me as is necessary. So AAAA still wants to look at CCCC. The switch looks at its MAC address table and it says, I don't know where that guy is. I don't know where CCCC is. So what I'm going to do is I'm going to send it out exactly the same way that hub worked. I'm going to send it out all ports except for the port that I'm receiving this on. So unfortunately, it still goes out to everybody. Okay, well, no real efficiencies there. The efficiencies start showing up when CCCC responds back. So CCCC responds back, and the switch now sees the port that CCCC is on as being port number 5. Because it sees that CCCC is on port number 5, and it knows that it's trying to respond to AAAA, it looks at its MAC address table and it says AAAA is on port number 1, so now I'm going to send that traffic directly down to port number 1. Likewise, any further communications between AAAA and CCCC continue back and forth. Every single packet that goes through the switch looks up at its MAC address table and says, this guy is on port number 1, this guy is on port number 5, so I'm going to directly forward your traffic to those destinations. This isn't routing, this is switching or forwarding. Now, the great thing here is that these guys right here, B, 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 and D, 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 for the majority of the traffic that's going on, they don't see it. They're completely oblivious to it. And in fact, these two could be having their own conversation at exactly the same time. And no longer do we run into collisions or issues with two people talking at the same time on the same network. Yes, they're on the same network. Yes, they're both talking at the same time, but the switch is essentially able to connect these devices together so they're communicating directly with each other without negatively affecting anybody else. As new devices show up on the switch, well, their MAC addresses are added to the MAC address table, and then we're able to view them moving forward. As an example, let's go ahead and open up a packet tracer here. So here we have a packet tracer, and I'm going to go ahead and open up this switch right here. I'm just going to go ahead and connect to this switch on the left-hand side, and I'm going to run a command. First go into enable mode, and then I'm going to do a show MAC address table. Now, the show MAC address table is, well, exactly that. It shows me the MAC addresses in my environment. Right now, I can see, well, I have one MAC address. That is probably this router that it's directly connected to. We could find out for certain, but it's most likely the router. You can see specifically what port it's plugged into, and in this case, it's gigabit 01. And if I hover over the interfaces here, it will actually tell me that is gig 01. Yes. Something like that. So let's go ahead and look at one of these devices. So I'm going to look at this network device right here, or I'm sorry, this PC. All right, clear doesn't work. And I'm going to run ipconfig/all to get all the information about this machine, or all the network information about this machine. And I can see right here is his MAC address. It ends in 4AB6. So I'm looking for a MAC address of 4AB6. If I look back at the switch that I'm connected to, I do not see a 4AB6. So the switch doesn't know about me. Even though I'm connected to it, the switch does not know about my PC. Well, in order for the switch to learn about me, let's go ahead and generate some traffic. Let's look at the rest of our network here. Looks like I've got some 172 address ranges. So let's go ahead and send some traffic to them. We'll just go ahead and ping him. .172.16.31.2. We'll see probably the first packet will fail, but then it will continue through. There we go. First packet timed out, but then the rest continue through just fine. And now if I go back to my switch and I just up arrow to do that same show MAC address table command, I now see my MAC address ending in 4AB6. And I can even see what port it's on, is on FA01. So whenever somebody wants to communicate with me, they know just go to port FA02 in order to send traffic to it. And this is how the switches learn MAC addresses and how they build their MAC address tables. I have another switch over here. I could do exactly the same thing. If I go into enable mode, show MAC address table. Here I can see on FA01, most likely that PC that I just tried to ping, which was this guy right here. And in fact, if I look at it, I see the MAC address ends in 1DA7. And this guy right here is 1DA7. So the MAC addresses are automatically learned by the switches, and as they're learned, they speed up the switching, they speed up the delivery of the traffic to their end destinations in order to, well, one, speed up the traffic altogether, also minimize the possible collisions that might occur that would cause everything to essentially stop and then roll back and try again.